Hello and welcome back. Today we're going to continue our makeFX series. In the last lecture we saw how if we have a Python function like this, we can use makeFX to trace this function to capture this graph. And today we're going to look more into the code to see how this is actually done. But before we dive into the code, I want to talk about the dispatcher real quick. So for context, every time you invoke a PyTorch operator, it will go through the dispatcher. And one conceptual way to think about the dispatcher is a series of hooks that will run. So for example, if you run something like a torch.sign, what's going to happen is it's going to go through here. It's going to go through a bunch of these dispatch keys, and you can think about these dispatch keys as hooks or functions. And some interesting ones are, for example, autograd. So if you see a torch.sign, you'll typically write a torch.cosine in the backwards graph. Functionalization, so if you have mutations, we can handle that. And then this is the most interesting one. So this is, it's called Torch Dispatch Handler, and both PyTorch internals, but also users can hook into this to basically put a hook right before we actually invoke kernels. And there's a bunch of different modes, but the mode that we care about here is this proxy mode. Now, taking a step back, what is like the right conceptual way to think about these hooks? One way I like to think about these hooks is imagine you have a camera on a highway, right? So like this camera can see all the cars that are passing by, it can see all the license plates, etc. And in many ways, this proxy mode hook is like doing that, except instead of cars, you're watching the operators go by. You're seeing all the PyTorch operators that are being called as you're tracing. You're seeing all the input arguments, you're seeing the output arguments, etc. And in the same way that you can use the highway camera to issue, say, speeding tickets, you can use this proxy mode to recreate a graph from all the operations you've seen. Okay, so now let's go look at the code. So one of the ways I like to understand code is to put a breakpoint in the constructor of very interesting classes. And here we're talking about graphs, and so it kind of makes sense to breakpoint within node construction. So here in torch.fx node.py, we see this class node. We breakpoint, and then we can inspect the stack trace. So this first one is actually quite straightforward. Basically, when we create a graph, we want a root node. And so we'll create a root node, not very interesting. Here we see that we create nodes for all of the placeholders. So placeholders are the inputs to the graph. And so you can see, where is it? Create args for root. You can see here that basically for all the arguments to the function, we will create a placeholder node. And here you can see that this is the name of the placeholder, it's X. And then if we skip forward, you can see Y. And now is where we get to the interesting part. So you'll see here that we're creating a node for add underscore. This is the mutating add we saw in the last lecture. And if you go up the stack trace, you'll actually see that in this one, we are creating it via this torch dispatch hook. So when we make fx a function, we actually activate this proxy torch dispatch mode. And this is the equivalent of the highway camera we were talking about earlier, where as we're invoking the code, we're capturing all the ops that are being called. And when we capture the ops, we get some nice data. So we see that the arguments to the operator, we see the actual operator itself, this a10.add underscore. And we can use this to construct a graph. So in particular here, you can see that we can create the node with these arguments, x1, 100, add underscore, etc. So in a different lecture, we're going to talk about kind of the intricacies of proxies and nodes and why you need a proxy over a node. But for now, you can kind of think about them interchangeably almost, where they're just kind of these nodes in the graph, right? So after creating a node in the graph, this create proxy thing, we still need to execute the rest of the code, right? And we were talking earlier about this idea of shape propagation. Well, how do you know the shapes at the end? Well, you have to execute every single operation and record there's the size and strides of the tensors from the operation itself. And this is where this comes in. So remember, like the dispatcher, you're kind of layering these hooks, but the hooks have a responsibility to kind of continue the dispatch, right? So after recording into the graph, we're actually going to invoke the actual kernel, the actual function with the arguments. Now, I'm not going to go too much into detail. You'll notice here that these are fake tensors. I have a video on fake tensors and fake process groups, which I recommend you watch. But at a high level, what this is going to do is it's going to run what's called a meta-kernel, which basically will calculate the size of the strides without actually doing the computation. And so it's a lot faster, more computationally efficient. There's a bunch of other stuff you can do, but you can see at the very end, we return out, right? So we actually return the result of this kernel call. So we've covered a lot, but hopefully you can kind of start to build an intuition on how this graph capture mechanism works. We are installing a hook, this torch dispatch hook. We're actually running either real tensors or fake tensors through the code. We're executing the code. And as we're executing the code, we're recording all the operations that are being run, their arguments, their outputs, and we're basically constructing this graph on the side. And so after you finish executing all the code, you just so happen to have also created a graph. So yeah, hopefully this was helpful. We'll continue down this series. We'll talk about proxies, torch function, etc. But hopefully you've been enjoying the series so far.